What's up, Chem fam? This is Lit Chemistry, where theory meets excitement and concepts spark with clarity. Today we are going to learn a really interesting topic, allotropy in carbon and its compounds. You already know carbon is everywhere around us. But the surprising part is the same carbon can behave completely different depending on how its atoms are arranged. Let's see how. So first, what are allotropes? Allotropy means an element can exist in more than one physical form in the same state. These different forms happen because the atoms are arranged in a different pattern. For example, think of Lego blocks. If I arrange the same pieces in one way, I can make a house. If I arrange them differently, I can make a car. Same pieces, different structures, different results. Similarly, carbon atoms arranged in one pattern form diamond, in another pattern form graphite, and in a cage-like pattern form fullerenes. And because of these different arrangements, their properties also change completely. Let's start with diamond structure. Each carbon atom is tetrahedrally bonded to 4 other carbon atoms. This forms a rigid 3-dimensional network. Properties: hardest known substance, high melting point, does not conduct electricity, can be lab grown under high pressure. So what does these properties and structures actually mean? Because of this strong structure, diamond becomes the hardest natural substance. We actually use diamond tipped tools to cut glass or metal. That's how hard it is. It also has a very high melting point and does not conduct electricity because it has no free electrons. Even the diamonds used in jewelry can be made artificially in labs by applying extremely high pressure. Now look at graphite structure. Each carbon atom is bonded to 3 other carbon atoms, forms layers of hexagonal rings. Layers are held by weak forces, so they slide easily. This is the very important point here. Properties: soft and slippery, good conductor of electricity, black and opaque, used in pencils, lubricants and electrodes. Why exactly graphite is soft and slippery? So the reason is, our pencil works when we write. Thin layers of graphite slide off and stick to the paper. So technically, when we say pencil lead, it isn't really lead, it's graphite. Graphite also conducts electricity because it has free electrons. That's why it is used in mostly electrodes, batteries, and even as a dry lubricant. Next is Buckminster fullerene, also called buckyball. Let's have a look at the structure and properties. Structure: made of 60 carbon atoms arranged like a football or a soccer ball. It contains pentagons and hexagons forming a spherical structure, round or spherical structure. Properties are hollow, cage-like molecule, as you can see in the diagram or the picture. It's very light, shows unique chemical reactivity, used in nanotechnology, drug delivery and material science. This is the very important use or property of this, not property, application. So let me explain the properties. This structure makes it hollow and very light. Fullerenes are special because they show unique chemical behavior. They are used in nanotechnology, drug delivery systems, and even in developing new materials. For example, scientists can put medicine molecules inside this cage, inside this structure, and send them to specific cells in the body. That's how it works. In conclusion, these are the 3 important allotropes of carbon. Same element, totally different behavior.